Hi everyone, my name is Arvinichi and today we'll go to the next lesson in the Substrate create. In the previous lesson, you create the first substrate and make a node template and interact it with the front-end template. And in front-end you will see a palette. And what is a palette? And in this lesson, we will answer this question by adding next palette to your runtime. And this lesson for a beginner, and make it in 2 hours, and you write it by Rust and Frame. As you saw the create the first substrate blockchain tutorial, the substrate node template provides working runtime that you can use to start building your own blockchain. With the runtime, you will open the folder of the node template. Yeah, node template. Okay, go to a runtime. Yeah, it's either 3 file about build the project, and cargo is set up to run the Rust language. And in the src file, you see a library is written by Rust language. So the node template includes a runtime that is constructed using Frame development framework and a few modules called Pallet to get you started. In this tutorial, you will learn how to add the next palette to the node template. You can follow similar patterns to add other frame palettes to your runtime. Maybe you will add a different name of the palette, like Iron palette or Alice palette, or so on. However, you need to configure each palette with the specific settings it requires to use it. This tutorial illustrates how to configure the settings each palette requires, but not the specific settings that apply to each palette you decide to add your runtime. So before we even get started, let's lay out our objectives. So the first step, you will add the next palette to your node template, and then you implement the next palette configuration trait. And last one, you use the front-end template to interact with the next palettes. So in this lesson, your learning outcome learn how to integrate the frame palette to your node and runtime. Familiarize yourself with customizing the palette configuration trait, and learn how to publish a custom palette to the Create.io. It's a community. Yeah, many project or tool in this homepage. Okay, and how to add next palette to the node template. The next palette allows blockchain user to pay deposit to reserve the nickname and associate it with an account they control. To add the next palette to the Substrate node template, first one, you open the terminal. Okay. And change the root directory for the node template. Yeah. go to the node template, you use the cd command to the substrate node template. Yeah. And open the runtime cargo.tom configuration file in the text editor. Runtime cargo.tom. Yeah, open it. Okay. The cargo.tom. Yeah. Step 3, import the Pallet next create to make it available to the node template by runtime. By adding it to those dependencies. In this file, you will see the Pallet dependencies. Oh, yes, that is dependencies. Okay, you will see the same construction in this. Yeah. And you will add the Pallet next. So you see the codec, Pallet over, Pallet balances, frame support. And last time I use the Pallet next in this file. You can see your frame system. Okay, runtime API. That is Pallet next. I added this in the last time. Yeah, you can copy it and paste to this file. And this dependencies section, the default features equal false. Yes, you see this false. Setting specifies that the Pallet features are not used by default when compiling the runtime. Instead, the features that are compiled for the runtime are controlled by specifying which features to include. When you compile the native Rust binary list in the separate features section. Because the Substrate runtime compiles to both a native Rust binary with the standard library functions std and a WebAssembly. In the short, a worms binary does not include the standard library. The Pallet features that get compiled depend on whether you are compiling the Rust binary or the WebAssembly binary, no std. For more information, compiling std or no std features, see the Rust embed book. Okay, you can see it. So you want to know about std or no std command, you can open this documentary. Sorry for interrupt because I have a phone call. So we will use the std. Okay, in this presentation, the std and it will use some student use part. This part is quite done. The std I will protect and the is you and the code and the wings is how to things no creature so for the process to mark the rest you so you in the data how to or and the premise and I will So for introduction to editing Cargaton file, you can see the Cargo reference documentation. Yeah. To add the palette, next create to the list of features to be included in the SD feature set by adding the following live features section. So you can open the Cargo Tom and you see the SD palette. Yeah, you can see the features default STD, and in STD you add the palette outline, palette balance, and palette mix. Yeah. So if you forget to update the features section, you might see errors similar to the following when you build the native libraries. So step 2, check the new dependencies result correctly by running the following command. So I will running this command. So after you running it, you can see the finish is a signal that you will check complete and with no error. And you see one warning. So you can take a look back in the code. See what's wrong with that. This is a command. This command, the note, and it's not in this file. Okay, you can look back soon. You see in the next step, review the configuration trait for the next palette. Every palette has a Rust trait called config that is used to configure the parameters and types that the palette needs from the runtime. If you review the commands for the runtime in the node template, you will see the examples of using the configuration trait to define and tune parameters for each palette. Most of the palette-specific code required to add the palette is implemented using the config trait. To see what you need to implement for the next palette specifically, see the palette mix config documentation or the definition the trait itself in the source code of the next palette. Okay, you can take a look in this documentation. Okay, this will initialize the event, the currency, the web reservation fee, the slot first origin, means down max length, and it's the event, it's overarching event type. currency will make a currency trade, and you get back the main document. In the shoot scope for next pallet, the complete trade declares the following types. You can see it. Pallet contain is the same as this documentation. This may be the features of that you want to configuration. Yeah, I think so. Review the implementation of the balances palette. Just like you use the balances palette as a template for importing the next palette, you can use the balances palette as the example to see how to implement the config interface for the next palette. What you want to do, you go to Substrate node and go to runtime and src and open the libs.rs file. So locate the balance palette section and note that implementation consists of two parts. Yeah, you will copy this code, and this is a two-part to this program. Okay, and I will copy it in the last time, and I will show you. This is a palette. So you can see, I will copy it to that parameter types. We will make a constant as this potential deposit and the max loss. And I copy the imp plug to the config for runtime. Note that you must keep two variable of the file is max reverse and the reserve identifier. Okay, note that. Don't forget. And maybe you will create a command. Something I want to see before at this code block. I can see. Yes, I will delete it. Yeah, and save. So the imp palette balances config block allows you to configure the type and parameters that are specified by the balances palette config tree. For example, this impile block configures the balances palette to use the unit 128 type to track balances. If you were developing a chain where it was important to optimize storage, maybe you can change that value about the U64 or the 32. You could use any Unisite integer type that was at least 32 bits in the size, because the balance type for balances Pallet config tree is bound by the at least 32-bit unsigned trade. Okay, the minimum is 32. Okay, to the next step. Implement the next Pallet config tree. Now that you have seen an example of how the config tree is implemented for the balances palette, you're ready to implement the config tree for the next palette. To implement the next palette in your runtime, first step, open the lib. Okay, this lib file. After the last line of the balances code block, add the following code block to the next palette. Okay, we can see the palette make config for runtime. Okay, the event max length. You can copy this code, copy and paste in this. Paste. Step 3. Identify the types of next palette exposes. You can find the complete list of the types in the contract runtime macro documentation. And contract runtime. You can see in this file. The next palette uses the following types. Pallet storage, because it uses the pallet storage macro. Pallet events, because it uses the pallet events macro. You will notice that in the case of the next pallet, the event keyword is parameterized with respect to a type T. This is because at least one of the events defined by next palette depends on a type that is configured with the configuration trait callable functions, because it is patchable functions in the palette code. And the palette type from the palette macro. So next step, you add the next construction time macro to the contract runtime. Yes, it is contract runtime. You can see it's the same, but you need to add the next palette to this function and save it. The next step, you will check the runtime file by run this command. Now wait for a short time. When the build completes, you will see the finish tab optimized. It's about 1 minute 24 seconds. and it's done warning. That's because I delete this comment. Okay, and the last step, you need to build copy and paste one. It will take you a long time to start a node. Here I complete build the node template after the 7 minutes 42 seconds. So next step we need to do is start blockchain node and use the next palette. And after your node compiles, you are ready to start the node that has been enhanced with the nickname capabilities from the new palette and interact with it using front-end template. You start the local Substrate node. Open the terminal shell and change the root directory to Substrate node. Okay, it's in the directory in Substrate node, and start the node development mode by running the following command. Okay, I copy it. Yeah, node is start. So the node template command line options specify how you want running node to operate. In this case, the negative that option specifies that the node runs in the developer mode using the predefined development tree specification. By default, this option also deletes all active data such as keys, blockchain database, and networking information when you stop the node by pressing Ctrl C. Using negative that option ensures that you have clean working state anytime you stop and restart the node. If you close this, we will delete all the data node is running. Verify your node is up and running successfully by reviewing the output displayed in the terminal. If the number at the final line is increasing in the console output, your blockchain is producing new blocks and reaching consensus about the state they describe. You see the finalize. Okay, then I will keep this terminal and continue with the front-end template. We will open the new one. And the same thing, we go to the Substrate front end template and start by join start. Okay, waiting for a little time. Here after run the front end, let's see, compile successfully. We have a host at the 8000 localhost, and you see this front end the same as the previous lesson. But take a look in the palette interaction. You can choose the next. It's the new palette we add to this node template, and we use some command with the palette. Example, take a look in the documentation and use the set name. Okay. Yes, set name, and we can typing the name. Is no longer than 32 characters. I will type something with the name signature RMG Substrate, and then we sign. We sign to execute the function. Yeah, it's running, and you see the events. 16 strings success. Next name set. Yeah, you can see the finalized block hash code. And you see the balance record and balance revert. So observe the status called events emitted by misspelling. So in this front end, you can query information for an account using the next part. And if you want to see the information to storage for Alice, you can in the palette select query okay, and Unix and name it, and you will copy the first address here. And you see this is this script, the hash code. The return type is a tuple that contains two values, the hash encoder nickname for the Alice account, and the second value you see the amount that was referred from the Alice account to secure the nickname. Oh, it's 100 reverse. If you were to query the next value for the name of the Bob's account, you will see the none value returned because Bob has not invoked. The set name is patchable and it possesses the funds to revert nickname. You see, this is Alice, and I want to see the bar. Okay, copy it, paste, and query. Yeah, it will return none. Explore more advanced topics. This tutorial uses the site built-in to the input the name detachable function and use the box count ID as a function's argument. The name function must be called by force origin that was configured with the next Pallet config interface in the previous section. You may recall that we configured this to be the frame system's root origin, not templates chain specification file used to configure the pseudo type. Give us access to this origin. Okay, you take a look at here and the pseudo palette. Oh, and the front-end template makes it easy to use a pseudo palette to detach a call from root origin. Just use the pseudo root. You see, this is pseudo and invoke the dispatchable. Since we just use the site built-in opposed to the pseudo root, the function will detach the site origin associated with the Alice account as opposed to the root origin. Okay. You can see the pseudo set key. Oh. We can try the next encoding. Back to S3. Yes. Encoding, and we copy the bar address. And we'll put the pseudo current transaction status block. So we see the event. Wow, you can see the finalized block hash. And you will notice the event to the function called the successful departure. Success. Yeah, you can see it. That origin arrow was emitted and is visible in the events pane. This means that Alice's account was still charged fees for the detach fee. You can see, yes, fees, pay fees, but there wasn't any state changes skill because the price follows the important verify first write last pattern. Now use the pseudo button to detach the same count with the same parameter. Okay, I want to try it again. Oh, you can see. Wait for a minute. A pseudo pallet permits a series run to inform network participants that the root originally patched a call. However, you will notice that the inner dispatch failed with a dispatch error. Let's see this arrow. Okay, pseudo. The index number relates to the pallet from which arrow originates. It corresponds with the index position of the pallet within contract runtime macro. The arrow number corresponds with the index relevant variant from the pallet's arrow enum. When using these numbers to find pallet arrows, remember that the first position corresponds with the index 0. In the screenshot above, the index is 9. Yes, index is 9. And the arrow is 2, third arrow. Depending on the position misspelled in your construction runtime macro, you may see different number for index. Yes, it will change. Regardless the value of index, you should see the arrow value is 2, which corresponds to the third variant of the misspelled arrow enum. This shouldn't be the surprise since Bob has not yet triggered a nickname, thus it cannot be feared. So you can see the module arrow index is 6 and arrow is 2. Okay. You should confirm that Alice can use the pseudo button, invoke the QName detachable, and forcibly clear the nickname associated with any account, including her own. And it can kill the Alice? Yes, that actually has a nickname associated with it. Here are some other things you may want to try. Add a nickname that's shorter than the mini-nick length or longer than max nick length that you configured. With the next palette configuration trait. The nickname for Bob, then use Alice account and pseudo button to forcibly kill Bob's nickname. Switch back Bob's account to the dispatch clear name function. And we go to Bob. Switch to Bob's account. Go to Bob. Go to the Bob. And dispatch the clear name. Okay. Make clear name and sign Probably you can see it's moderate. Let's arrow tube. Adding other frame pallets. This tutorial illustrates how to add the palette to runtime using the next palette as an example. However, it is important to note that each palette is a little different. If you aren't sure how to add the specific palette, the best place to look is the runtime from the main Substrate repository. Yeah, it's a runtime. Unlike the node template used the tutorial, the runtime in the main Substrate repository includes most of the pallets available in the library of the car frame pallets. Refer to the runtime cargo time file for the main Substrate node runtime to see example of how import different palette dependencies. Refer to the bin analytic file for the main Substrate node runtime. See the examples how to configure the runtime include each palette. Generally, we can copy code from the main Substrate node runtime as a starting point to include the palette in your own runtime. So, in the next step, you can publish your own palette. By now, you should have successfully imported the unique palettes. In future, you will write your own palettes to execute your application-specific logic. In those cases, you may want to share these palettes with others. In this section, you will cover how to publish your own palettes for the users. Option 1. Publish on Github. I will use it. We have a Github response story and push a palette code. Using the following okay, we can use the cargo can use the curving okay, I will go to my GitHub sign. Okay, in my GitHub, I got a username your username, okay, your palette, palette array, okay, person 1100. So it's complete and check. And in dependencies you can add in the crates IO. Yeah. Yeah, you can write it. And this is all about today's lessons. Goodbye and see you in the next time. Thank you for watching. Don't hesitate to give me a question. Bye.